my guest this week is Mohit Tiwari, Professor Mohit Tiwari, who is co-founder and CEO of Symmetry Systems. Mohit, your entry into the cybersecurity industry was through academia 10, 12 years ago when you started trying to figure out first principles for data security. Can you take a step back and talk about, your initial interest in this space and what prompted this focus on cybersecurity?
My background is that I was doing a PhD at UC Santa Barbara at the time, and since then I moved to Berkeley for a couple of years and then to UT for a faculty position. And all the way through, I was just very, very keen on an area called information flow control. And it's this whole very long-term area, about 50 years of research has gone into it, around how is information flowing through your system. And system here means your endpoint device, your cloud, your applications, all the SaaS services, right? And the whole goal is that can you ask questions about data, in a way that is independent of what applications or systems it flows through. Super interesting area. I was working on this, and the applications were endless. People apply this for core security problems, and I personally, around 2011, got very interested in applying it to access control and privacy related questions. The whole goal is very simple. If, Ryan, I send you a message, I want to know only you saw that message, right? But now take this from a message to any application, right? You can do this for Signal, using Signal for messages, but now think about medical applications. I shared something with a doctor or my family member, only they see it, right? Move it to financial applications, move it to other kinds of personal applications. How can you refactor privacy out of, other, business logic that, it's all over the app. So that's
Right. Can you linger a little bit on the information flow control concept? What was the impetus for research in this area? You said there was a lot of previous research, and then over the last 8 to 10 years, you and your team you advanced it as well. Define this information flow control within the context of, a prior world that you were researching prior to cloud, prior to this digital transformation we've seen, and how it translates into these first principles that you've seen now as our networks become more disparate and, complex.
That's really interesting. Information flow control is actually very, very simple. You want, if you think about even personal questions, like I said, I sent Ryan, some health information. I want to know only Ryan. So I think this is the goal. The same thing if, replace me with an organization running a compliance program. I want to know that EU data only lived in EU. It didn't travel through any service to non-EU places, right? This is like a very common compliance.
Right.
You can move into security questions. You say that, hey, Okta had a big breach. They had to answer, is customer data affected? Some contractor somewhere, those credentials or laptop got compromised. Is there a path from there to customer data, right? And specifically,
and not only answering that question, but answering it in a timely manner. Because I'm glad you bring up the Okta example, because what we found out in the Okta example is that the true postmortem came a month and a half later. And they had already got caught up into problems around disclosure and so on, because identifying this blast radius in a timely manner becomes complicated. And that's our current status, right?
Yes, exactly. So I think this question, that's why this is the most attractive part about information flow control is, you can change the actual questions, right? But the shape of the questions is always what happened to this data, even though many different identities acted on it or many different applications acted on it. What's going on with the data? That's the shape of the question, whether I as an individual am asking it or whether companies are asking it. So that's where as an academic, you're always looking for okay, what's the one place to strike a hammer where if you make a dent, you sort of, you have huge impact. So I, as with all the people who worked on the space for 50 years, they all were sort of chasing after this dream that, how can we make information flow control really practical, and practical in a way that it doesn't burden the cloud providers or infrastructure people. It doesn't burden the application developers. It doesn't burden me as a user. My questions should remain simple. These kind of things. So there's a whole much more detailed design space around making it operational, right? How do you bring it to life?
Right. When and how did this research project and all the work at UT, University of Texas at Austin, when did the flip switch in your head that, you know what, we might have a solution here, we might have a problem, this is, there's a problem statement that needs to be asked, this information flow control concept is heavily fleshed out. Give me what was the tipping point in your head that, you know, we can make something out of this?
That's it.
And how does that work with the university? Just help the audience understand. Like, how does that work when a research project comes out of a lab and then it's heading to be commercialized? Walk me through a little bit of that.
Nice. So those are like almost two kind of back-to-back questions that are really interesting. So for me, I would say that this project was I mean, the first step was just finding collaborators who get into it as much
Right.
as you, so that now you just are not doing anything else. You're kind of just really, living in this.
You're
This
still
is
at
at
UT.
UT. So I ran into my
Right.
current co-founder and ex graduate student Kason around 2012, 2013 timeframe. We did a project around information flow in the hardware, and then around 2015 we sort of both committed, and then I had to find one more person to help add bandwidth. So I found my brother and asked him to sort of join forces. So Kason, me, and Puneet, my brother, we sort of banded together and committed to let's go try to build something, make this real. And the-
So, yeah, but back up to when did you know that there was something here to be
right.
built? Was there like a first principles tipping point? Was there something in computing that happened that moved it from this 50 years and 50 years of prior research, another 10 years of you guys doing this? What triggered this idea that there's something here?
Right. So I think that's the biggest tipping point to me. Just was almost not even about information flow. It is that we could see that applications were moving towards Docker was pretty big already by that time in
Right.
2015. Your Linux containers are morphing into much more usable forms, and people are chopping things up into microservices. You can see the first set of orchestration frameworks had already been out, and Kubernetes was just about to start. So it was sort of in the air that big monolithic applications like like Office 365 type of applications, or the classic of.
And you guys had already seen this coming? I mean, you had predicted this as part of your research that you knew that microservices and this was going to be the next
So in the
the
research line,
logical
it was
place for you.
almost a done deal already, right? If you look at,
Okay.
I think Mesosphere was the first orchestration project, came out of Berkeley. That's another example of, academic research making it into production, close collaboration
Right,
at
right.
Twitter, I think. And yeah, I think, I mean, at Berkeley at least, so I was there 2011 through 13, and it was sort of like in the air that you could essentially get applications shipped as microservices in containers. It's just good for, it's like inexorable gravity pulling the world towards that. A lot of details were to be worked out. So as a result, like when we built the first version of what we call data containers, where you're orchestrating data inside containers instead of applications, right? And you do it in a
Right.
way that, so we worked on that project, but I think this tipping point that you could just take big, useful, hairy applications and easily inject a new orchestration layer below it, this was possible. Now you can get really creative with
Right.
what is in that box. Is it one monolithic kind of like application functionality, or is it that thing chopped up into small pieces, right? Each handling small pieces of data at the time. You can just get really creative. So this
Right,
orchestration
right.
frameworks, I think, was the main tipping point, and microservices.
Right. And just quickly, how does it work? Does the university encourage this? Does the
Yeah.
like help me understand like how does a university research project gets commercialized and what's the structure of how that
So yeah, I
works?
can walk through our story. I think broadly, I would say at UT Austin. So again, this is very specific to each university. I think at UT, the whole charter was have impact. Right when you join as an assistant professor,
Right.
they're not prescriptive about it, and we spent a lot of time. We found, so our story was that we found a hospital, Dell Children's Hospital. They handle complex care problems for kids, right? And their whole mantra was healthcare happens outside the hospital. It had to, because the kids going to a special needs school, there's social workers, school nurses. So they can't have a HIPAA compliant EMR app locked into a hospital desktop server.
Right. And this was your first
No,
prototype, or this was just as part of the research?
this
Okay.
was kind of our goal. Like we started working here, did a lot of work. So at that point, we knew we wanted to push it out, but we didn't really like trigger patent offices and all of this stuff. So we did
Right.
this
Right.
foundational work as open research, right? And then
Okay.
around 2019 or so, we were like, okay, we need to spin out. So there was a clean kind of break off point where we said, okay, here are all these ideas, prototypes, these are all in the public domain. And now let's go try to build something more custom, kind of more closed domain, just to figure out right how it would work inside the company.
And what is that custom thing? Let's get into a little bit of the product now. So you've come out of
Right.
UT, got some startup funding you got some venture capital startup funding, and now you have your first principles in place. You had your first prototype built out. Now we're getting ready to commercialize this. What does the product look like now, and what does it do?
Right. So we have morphed it quite a bit over the last 2.5 years. When we came out, it was kind of native to a containerized ecosystem, right? Containerized workloads.
Right.
What we learned, so we met Will Lin, he's at ForgePoint, Byron Alsberg at Prefix. So both of these folks had really good kind of network of CISOs or security practitioners that we talked to. And what we learned is, I mean, containers are great, but the cycle is slow of mass adoption. There is a huge
Right.
movement that is only now still going on just to the classic, EC2, S3 classic cloud, not even the containerized part of the cloud. So we just rethought our plumbing to be okay, instead of only focusing on containerized workloads, let's make it available to just general, classic cloud workloads. And we essentially we call this product now Data Guard, right? And it's a very systematic walk through the NIST kind of life cycle of protection mechanisms. You come in, whether it is network applications or now data, you have to sort of identify, get visibility into the problem, and then move into either protection, detection, response, and so on. So we built the product such that you start with visibility, right? Get sort of strategic
Right.
awareness of where is your most valuable data, how is it protected today, right? Where do you actually need intervention, and then help make the interventions, whether it is detect, right? Sometimes you can't change what you have. You just can only put
Right.
seatbelts. And sometimes you actually can go in and change, like, oh, genomic data should never be here, here, and here. Let's go move it, lock it down, things like this. So you can actually go into a protect motion as well.
Right. Right. I'm glad you brought up the NIST framework, because I was going to ask you about another one that I use, which is the Cyber Defense Matrix out of
Yes.
Sunil Yu. It's basically the same thing, but just like a simplification of the grid
Right.
format. What I'm hearing here is, with your product, there's way to even disrupt the framework. In a way, it disrupt the framework and give security folks the ability to answer these questions, even if they don't own the data, or even if they're not responsible for even protecting that bit of data. I'm not sure I'm framing the
Yeah,
question correctly, but can you talk a little bit about how you view your data guard symmetry systems fitting into disrupting these frameworks?
I think you remark on something very interesting, that at least that we've also observed in the field, right? That there's the classic model that you have identify. Then once you've identified the problem, you can go protect it, fix the problem. Once you've
Right.
protected it, you go detect if something breaks and respond and recover. So I don't think NIST means it in this way, but it's easy to sort of have the impression that there is a pipeline of tasks that sort of go sequentially.
Right, that goes naturally, that flows naturally, and
It
it
doesn't,
doesn't.
right, right. And Sunil actually talks about it really well in from the cyber defense matrix, right? He talks of left of boom versus right of boom, right?
Right, right.
And our kind of finding is you're always in a steady state of boom. There are all sorts of small to big booms happening across your org.
All the time.
Right. So as you kind of go through and run services that provide visibility, like Data Guard or counterparts in CSPM, like cloud security, posture management. If you run, once you see the problem, you can actually put a seatbelt right away. right? Sometimes you say that, look, I found this analyst sitting on access to all this data that's really risky, right? This has like raw SSNs here and all of these things that should not happen. But security people don't might not know the full business context, right, across the company at all times. Maybe at that time it makes business sense for these analysts to have access to that data, even though you're kind of flirting with danger there. So, but what they can do is put a seatbelt, a detection response kind of seatbelt on it right away. You see the problem, you see that you're close to the precipice, but you know you can't really change it the moment you saw the problem. You have to go back, interface with the data teams, interface with the dev teams, and figure out a immediate solution, long-term path. All so protect actually takes very careful, well-considered actions, and sometimes that takes time. But detect, respond, you can see like, hey, here's a service role. This modifies all my permissions across my cloud. You know, it's not been used for a while. What's going on here? Let me put a seatbelt. If this wakes up, this is a dormant identity or, if this wakes, let me
Let me
know,
know.
right? You can do that right away. So we've,
Is this easy to explain to the modern CISO? Because there's a little bit of a disruptive view of how networks are how data is flowing within networks. When you, because prior I saw the description of data source object security, which is, it narrows it and describes it even better within this information control flow concept. The question is this difficult? Is this a difficult concept to explain to a buyer, or do people get it as soon as, like, is this something that has to be experienced, or is this something that they get as soon as you start to describe it?
so I think the modern CISO is the part that you described. That would, I would say, there's like a fork.
No, we don't want to call CISOs not modern, so let's call them just
I would
CISOs.
say that if someone kind of, if you think about it, just first principles, right? Like, there's an incident. Would we just heard that
What happened?
80% of the time is spent figuring out what data was affected. You could get that
Right,
at your fingertips. Wouldn't so? I think it makes first principle sense, but just the way the security orgs are set up today, there is an IAM team that goes from
right,
identity to permissions to some service roles, and they stop there. They don't go all the way to data. There are SOC teams, right?
right,
They have very little business context, but they have to sort of reverse engineer it almost, right? Looking at network
right.
flows and
Black box it,
right.
right.
So it almost like comes down to, and then there's the classic DevSecOps people who are in the app pipeline, CI/CD, container scans, all. So if you ask this
Right.
question, the biggest part is logically this problem, this makes sense, but where do you put it in? Which bin? What budget line item does it come from? Which team owns it? That's where the biggest kind of like challenges occur for the CISO. It's like, and typically it ends up being like, oh, Alice, she's the most sort of well connected across and kind of sharpest person. I'll bring Alice into the engagement so that she will know what to do. Like, I think that's kind of how our whole thing started with initial customers, that the CISO just found the mover and shaker within the org.
Right,
And
right,
in
right.
steady state, all three teams use us, right? If there is an incident, you fired your kind of core SRE and you're freaking out about the last 30 days, what was this person doing? You come in and you just look at all transitive activities, that is the identity, right?
That's tied to that
Right,
identity,
all
right?
the way to data. So you want, so I think operationalizing this, who owns it, has been the kind of core question that they've had to work through, right? Um, so
Got it. And I asked that question because you're building out a business, and fitting into these established categories become important, because now you have to figure out where does budget
yes,
come from for a CISO to buy the Symmetry Systems
yes,
product, and your category is data
yes.
security, which is a catch-all for
Yes.
everything in my mind, right? So when you think about categories, if we can spend a minute here, can we just go all the way back and describe in your mind this catch-all of data security, and where do you fit? And are there multiple fits? Does the CISO have to buy 10 different types of products to fit here? Or help me frame the market you're in.
That makes sense. So just starting from data security, right? Kind of how to break that down. Yeah, I
Yeah.
think that's so when you're going from sort of 0 to 1, this is a huge problem. But and category TM is sort of defined by analysts and such. Like I think
Analysts and the analysts, yeah.
me being in a category anyways, but it doesn't matter if I think it. But I think what's going on is that like the data security, hashtag category is now sort of evolving, and a range of analysts have kind of caught on to it, and they're starting to delineate it. And what it used to be typically was encryption key management, right? So there's Talis, there's open source projects like Vault that you could kind of think about that. Data security means, is it encrypted? Am I doing my certificates and, key management correctly?
Right. HashiCorp Vault and those guys in that
Right,
space,
right,
right?
absolutely. So that was basically like I would say the liked part of it, and then there used to be this like really sharp-edged space called data loss prevention, right? DLP.
The old familiar
Yes.
DLP world of, content inspection and trying to find exfiltration points, that kind of thing. A market that's been around for 15, 20 years and still hasn't disappeared in terms of
Right,
importance.
right. I mean, so that's the thing. Like, once things come in and they become part of a compliance check line item, the time
Right.
cycle for them to sort of be eased out is, I mean, 20 years sounds like tight. So 15 years is early days of DLP still.
But these two categories are still within the data, still big parts of the data security bucket, the encryption and the DLP content inspection
Right,
pieces,
right.
right?
So they're still in there. So I think what's kind of emerging, and this has really been facilitated by more like cloud data stores, right? Because there's this other like really niche like database, like things about database firewalls and look into the memory of it. It's very like database server oriented, and those are like
Right, right.
Imperva and Oracle have products in that space. But I think those are all sort of like misleading parts. So I think like longer term where this is going is encryption key management. That's a perennial evergreen space. It's gonna be there. The rest of this these were sort of like a wrong turn into a cul-de-sac, DLP and database server specific things. I think these are gonna evolve into just kind of data objects security, which is how are data objects flowing across all my kind of API centric data stores, right? So it's not about the database
Right.
server, right? It's about the data objects, and now I can track them all the way from SQL, NoSQL stores into object stores, into data lakes, and so on. And I can, so that was the other kind of tipping point here for information flow, right? Like now you can track these flows of data objects across your entire cloud data stores. Right.
Right. And and I noticed Gartner has even put you into like a little smaller subcategory. I don't know if you're happy about it or if this fits with exactly where your mindset is. Is this data security posture management? We're familiar with cloud security posture management, which is a different, somewhat different. Can you define data security posture management for me in terms of how you understand it and how you guys are explaining
Right.
it?
So to answer your question, I am pretty happy. I think this, in that NIST whole flow, we can reorganize, detect, protect, and such. But starting with visibility and moving forward based on evidence that, hey, here's the specific problem in my specific org, right? As opposed to do least privilege, right? That doesn't make
Right.
sense, right? Like it doesn't move people. So I think starting with visibility just makes a lot of sense. And I think a lot of our kind of conceptual things around visibility, Gartner kind of made this analogy to CSPM. The other nice thing is CSPMs have been
Okay.
pretty successful, right? Like there are companies that have flowered in that whole area. Customers know that they can justify, hey, look, we have CSPMs for workloads, right? We need DSPM
Right.
for data, and it just makes the business quote unquote side of things straightforward. And this is the tipping point. So starting off with DSPM is totally fine, and once we gain more momentum and we kind of show value that, look, we came in via DSPM, we changed your entire process by which data teams kind of bring in sensitive data, clean it up, and manage it. Right. We came in via DSPM, and now we have put in detection response tools that your security and product teams use. Right. Kind of it's built in into protect like CI/CD tools. It's built in into detection, kind of same SOAR type of workflows. That's perfect. Let's make a case for the rest of Symmetry's products using the DSPM as sort of a wedge. Makes a ton of sense
Right.
for me. So
Can you walk me through deployment? Is this something that require, like, what is the requirement around getting this thing deployed? And is there any sort of friction there? Because that's always pops up among buyers. Is like, you
Yes,
know, how much friction, how frictionless is deployment and getting results immediately?
100%. So there are two parts to it that I think are really valuable.
Or do you run on-prem as well in addition to being in the
Yes, yes.
cloud?
So that's where I was going to. So I think cloud
Okay,
native
sorry.
computing foundation tooling, the best part of that is that they actually make you cloud agnostic. You sort of like this floating in container land, wherever you can spin up a
Right.
VM and containers and find the right plumbing. Cloud just makes the plumbing easy, right? For very big companies, the entire cloud deployment is a really glorified, proof of concept for, oh, can I also bring you on-prem, right? So we
Right.
really like that. I think long term, you should have this question that, did my crown jewel data get affected by this incident? I need to answer it
Right.
across my entire real estate, not just one sliver here and then have to default into, you know, not as useful things here. So a single control plane that goes out and answers these questions makes ton of sense. On the deployment side, I would just say that, and I think Gartner also caught on, or not caught on to it, like they really underlined this, right? They kind of phrased this as this challenges quote unquote best practices, which is we live in the customer's cloud. Our whole model is how to be respectful to the customers. We don't want to add vendor risk. We don't want to take on, this model where we are sitting on all our customers' data, and then if we get breached, then all our customers' data is affected. And it's just like
And you did you engineer for that as well? I mean, how are you making sure that you're not introducing risk to the organization by being there, sitting, looking at
we
everything?
try our best. We basically, you can't just spin up data guard inside your customer's org, right? In a way like, admin password kind of a setup. Like there are IAM
Right, right.
controls, network VPC controls, key management, all of these things. It's not to say it can't be broken. It's to say that there are several layers of seatbelts that we have engineered such that when you spin it up, it spins up in a sequestered account with lots of controls around it. And now the security team that manages it, like they can bring on board people to help them, and it's read only to start. It just kind of figures out the posture, and then once we earn the trust, then we bring a separate small component that actually can act on it. And now we can plumb
I
together the
see.
read and write parts separately, right? The read parts has to do all sorts
Right,
of
right.
analysis, graphs, machine learning, whatever, right? Like, and it's bigger, so we don't want that in the trusted code base as much as possible.
Can you talk a little bit about traction? Like where are you where's your sweet spot? You mentioned healthcare earlier. Obviously, from what you described here, it's not limited to healthcare. I mean, every company has this same problem. But is there like a sweet spot where you guys are starting to gain some momentum?
Yes, so I think for us, folks who were already thinking about, like, if you go talk to healthcare, to financial services, to even hardware manufacturers have been in the news lately, right? Anyone who, when they think security, they index on, oh yeah, I either have my customers' data, that's if I lose this, I'm out of business kind of vibe, or I have my
Right, right, right.
own simulations, CAD files, ML, like IP, that if they index by the type of data they have as kind of the biggest driver for their security program, to me that they are like the early candidates. In steady state, everyone has customers and everyone should take care of customers' data, right? So we'll get to the sort of middle and late part of the adoption curve later. But
Right.
folks who know they have to answer for regulations around data, right? Um, I think this would be
It becomes a no-brainer in those categories,
absolutely,
right?
absolutely. If you are running an identity program, there's like this trope: identity is the new perimeter, right? It's catchy, but it's actually not true. When you say identity, it's authentication. Authentication is not the perimeter; it's the permissions around the identity. That's the perimeter. And the permissions are
Right.
naturally, in the best case, are around the data. Like, it's not about which server you have access to, right? It's what data is on that server, and what I so
Right. Usually in startup land, there's an incumbent everyone is chasing. One or two big incumbents, and then there's two or three startups that that are and you guys are obviously in the lead in your little in this category. The question is,
well then
is there an incumbent? Are you a subset of what like these DSP data security platforms provide? And is there a risk that the cloud security providers could embed these kinds of protection and visibility options into their products? Talk a little bit about like the competitive landscape for a little bit.
Yes. I mean, my whole take is we want a much safer, better kind of data-centric space. I want the cloud providers to build this. We want the incumbents to reinvent. And, the challenge for us is, can we still stay, the best? I think that's, so I think it's a good thing if folks try to build it. That's kind of how we approach it. But the space really is, as you described, there are classic incumbents. Like I think Imperva used to have a database firewall. They're now trying to rethink. Varonis has been doing this kind of things for endpoint. So they drop an agent on your endpoint and it looks through your drive it's like, again, like, so this was all like, this data-centric security vision makes a lot of sense. But these products incumbents were built for a older world.
A different
Yeah, it
era.
was just hard to get to data. It was like siloed in database servers. You have to get DBAs involved and, install an agent. And
Right.
it's just like really messy to operationalize it. The friction, as you mentioned earlier, was just too much, right? So I think like they'll
And that's changing. That's changing now with not
like
only products like yours, but the cloud providers are getting a little better and better every year at providing some of these tools as
absolutely.
well.
I think on the cloud provider, so that's like the incumbent side. There's the cloud provider side. That's sort of the below everyone, right? Like their goal is to just be the tide, kind of for this lifting up security posture for everyone. But it's really hard. Like I do not envy AWS and Azure. Like you see, like our you know community colleagues from Wiz and Orca, they keep finding, oh, here's the bug of the month, and actually you can access every single Cosmos DB in Azure or whatever, right? Like it's really really hard.
They have bigger problems. They have bigger problems than investing in engineering for this
Right.
stuff. You know?
I hope they do invest, but again, they'll have to solve. It's not like 100,000 people that are doing it. It'll be a team of 20 or 100 people working on this, right? And if we can't do better than that, we shouldn't be around. So that's
On this on the same issue of competition and building this business, I want to flip gears and ask you kind of like a personal thing. What was the hardest part of flipping your mind from academia to being not only an entrepreneur but a startup entrepreneur in cybersecurity that's ridiculously competitive and that's like incredibly noisy? Can you talk a little bit about the personal mind shift that had to occur, and what was the easiest part of it and what was the hardest part of it? Is there something in it that you still hate?
that's a very interesting. I think about that a lot. Just have this impression that folks think that academia and especially startups, like early stage, when you're trying to make a new product, these are very different areas.
Are
These are
different?
just
You don't view it as different at all. You view your researcher's problem solving as an
it's the
entrepreneurial
same. Yeah,
mindset.
absolutely. Because we don't know like what plumbing will work. What is the full workflow? Okay, I found some problems. What is the full? I can imagine that sure you will want to do this AIML or SIMSOAR or whatever, but turns out it's not the case. And turns out when you actually really probe the customers and understand the context they operate in, they have very strong and good incentives to do something else, right? It's just like
Right.
this act of like you make a hypothesis, but you test it really quickly, fail as fast as you can, and just be super open. And like when you're in research, you get really well-meaning people giving you really harsh feedback all the time. Harsh as in like you are wrong, kind of. It's not meant harshly. It's just like, yeah, you were wrong. Yeah, blunt,
Blunt. Right.
all the time. And this is perfect for startups. You just get told by everyone across the stack that like, yeah, this is interesting, but here are the 20 big problems. And then you have to sift through which of those 20 are fundamental and which are just artifactual. You just conveyed it wrong. Sort of sifting through and making,
The pressures are different though. The pressures have to be different though. I mean, what's the end goal of an academic project? A research paper?
like,
A prototype of something? Maybe I'm wrong.
I think pressure is mostly in the
Help me
mind,
understand it.
right? Like, I mean, this is a very, very tropey sentence. But if you think about who gets into the echelons of academia, of research specifically, these are like your worst classmates in some sense, by and large, like in terms of being competitive and ambitious. And it doesn't matter what they're chasing, whether it's like, if you go to Google, people are chasing L6, 7, 8, whatever, like it means
Right.
the world to them. Here there are people like, I want to be the one who invented X, Y, Z. I want the credit for. In startup, I want to, sell the most and make them. It's just like,
So you still have to have that competitive fire and energy inside. Like it exists
yeah,
throughout.
it's like, yeah, exactly. You sort of have to be excellent at in a very noisy environment where you get a lot of feedback and most of it might not make sense for you at this time. Most of it is
Right.
just, you know, lessons from the last 10 years just being retold to you, and some of it is super valuable and can kill your company any moment. So I think that part is not the easiest, but the one that transferred over the best.
Right, right. No, I asked the question because I mean, I've been writing about security for 15 to 20 years. I've been telling stories about companies and founders for all this time, right? And our industry has kind of evolved into this a flow of hype and a lot of marketing nonsense and a lot of drivel and a lot of just skeevy parts of our business, right? And then you come out of academia with your first principles and your clean approach. Was there a point when you get into the entrepreneur land and you're just like, what did I get myself into here? Because sometimes I feel it as an outsider. I look at all the nonsense that happens around the sales, the sales cycles and all the unethical things that we talk about all the time.
Yeah,
How do you navigate that?
I, you know, I, it's hard because, like, I mean, we are in this phase where we just get to interact with customers who have real problems. They care less about the hype. If you talk to Chris Castaldo at Crossbeam and Brian Castagna at Seven Bridges, and they're just so into the problem, and you just sort of get into it, and you're in the flow of trying to solve the problem. And I don't know, I read this somewhere. Someone had said, I think it was in Obama's book or something, right? Like, it's like, when you're having a lot of these like philosophical questions, just sort of like go back to your own personal first principles. Why are you in it for? And just keep
Right.
doing that more and more. And
So that allows you to discount the noise. Like you have your first principles, you're solving significant problems for very, very important people and very, very important data. And going back to the UT
yeah,
mantra of go forth and be great, right? It's like that's how you
exactly,
navigate it.
exactly. And I have a pretty long time horizon. Like when we started if you look at even just this area of information flow, big jumps were made every 10, 15 years. If you look at machine learning, right, like it's a winter from 80s to 2012 roughly until the GPU stuff came around. And you sort of have to keep pushing. And I just see the arc of this stuff is gonna bend towards better privacy. It has to. Like people want it. They keep making GDPR, CCPA. That's like non-engineering people telling our community what they want. They want respect.
Yes, go fix this. Go fix this. With the lessons, I mean, the messages from the regulators are very, very clear about where the energy needs to
Right,
be.
right. And Leah Kistner actually she's at Twitter now. She found the best phrasing that I've seen for this is, is it trying to like build with respect for your users, like for other people in the community, right? Like they could be developers, could be users, service providers. If you sort of keep this mindset, like a lot of these answers is sort of fall out. Building like for SaaS in the customer's cloud, insanely hard. It's going against the grain completely. But it was almost like not a question for us. Right? We almost never thought that. We want this world where, as a user, you have control, as a company, you have control and visibility into what's going on. It's just the right. If I'm a vendor, I want to just come in and give you a service. So if you sort of orient it this way, a lot of this stuff just falls out. Now it's a matter of bending the rest of the, like playing the detailed
Right, right.
game, and there's fun in that, but you can sort of zoom out.
Are you generally an optimist? Like you sound like you feel like privacy is something that can be achieved, and I feel like we're heading in the opposite direction as a society.
Yeah, I think like there is a time lag between when, you can see the engineering things and the business forces have shifted, like the winds have shifted. Like I think
You think so?
I mean, we should collaborate on a document that says why exactly. Yeah,
Documents
yeah.
it? Okay.
It's, the more the interfaces become open, right? The more you can come in and add your policy to drive how you want the underlying infra to behave and the apps to behave. And now to me, it's like there can always be an option that doesn't respect as much, like, the user's privacy and is surveillance, doing all sorts of things, but it offers it to you for free, and it's like a town square, right? And there's a space for that, but there's also a space for like, hey, this stuff is built to be respectful of your privacy, and this is like a more private space for you and your colleagues and your company, so on. And I just think the second option was really hard to build, especially a business around. And now the technical barriers are gone, and now we're sort of figuring out how can we build like functional business around it. So we're trying to be like, hey, we'll improve your security. Turns out that actually improves. If everyone protects data better, it improves people.
All right, I want to end here because there was a lot of as we were discussing this and as I'm listening to this podcast, you mentioned data firewalls and you mentioned access controls and just this access control and authorization, which comes back to zero trust, the whole concept of zero trust. Zero trust is now coming top down from government through executive order, just driving a lot of energy in federal world, which obviously will spin down. Do you get a sense that just let's look at computing as a whole, that the flow to where we are from, let me rephrase the question. Do you get a sense that this zero trust push or this concept, the zero trust concept, is something that fixes things once and for all, or are we always going to have daily breaches?
Well, so my take about zero trust is it's like a marketing person being very kind of like pushing the edge and maybe even going past the edge a tiny bit, right? But it makes you think like, and what it is really doing, the good part, the best part about it that I like is, it makes you think like, oh, you can't have absolute zero trust, but it is pushing you to think towards least lower privilege. How do you be more intentional about your trusted code base? It's never going to be zero. I mean, TSMC or whoever manufactures your chips, I mean, they're in your trusted code base, right? Whoever built your CPU or whatever, right? Like, so again, but you can, by being more intentional about it, you can reduce it. And right now we are in a spot where we, by default, just trust it a lot, right? Every application, you install an app, Node.js, boom, like, 10 lines.
Yeah, that's the current state. That's why I'm asking if from when you started doing research and you look at the cybersecurity, current state still feels like a free for all. I mean, it just feels like in 2022 we can't properly answer these questions that you're trying to help CISO solve, and two, even if you can, it's very expensive. The security tax is prohibitive. It's a theme that comes up on my podcast. I don't want to linger on it here too much with you. But do you get a sense that, I go back to the original question, is this even tractable?
I think so. I mean, again, it's not about optimism. I think that there are engineering reasons why the more you can, kind of turn your applications into floating blobs of functionality that come into
Right.
things that are more kind of, persistent, like data, right? You can build a layer and service meshes in the computing side. Like they're doing this thing, right? Like, hey, free the business logic from doing infra work. Turns out that infra work can include security. Like we are trying to do like the first step, data firewalls or data containers.
Visibility,
Yeah,
right.
visibility, access control. You can layer in so much more, turn this into like a moving target defense, start doing like N versions. One of my students has a paper coming out that says, we can run workloads in 3 versions, like N version programming, and if one blob got hacked, that's fine. Like we'll figure it out and we'll kind of correct for it on the fly. This is just starting. We'll make very very big dents into kind of reducing the TCB. I feel like there is most reason for having technical reasons for having optimism right now, and it again won't go to zero.
Okay.
Breaches won't go to zero either, but we can improve it a lot.
Last question. What is next for Symmetry Systems? Where are you now? You're in. Are you in a phase now where the product is completely deployed? You're in growth mode. Where is the company and what's next? What are you excited about?
Yeah, so I think the product will keep getting improved over even like the next 1-2 years. We are at a point where we have been able to drive pretty significant outcomes for Fortune 500 companies or even growth stage startups. We are very excited about our partnership with Accenture. We have another one starting up with Trace3, and they're sort of spreading the gospel and making it kind of, saying, hey, just try this out, try this out for a month, and look, it's in
Right.
your cloud. takes an hour to set up, right? I personally want to make it willful negligence for someone to not try out a data guard. It might be a Symmetry data guard, or it might be XYZ data guard.
Anyone, just the initial benefits you're saying is just so
Yes.
eye-opening. And how soon?
So you can see results within a day, and within a week of activity, you can see how it's being used. Within a day, you can see what's the permissions. Within a week, you sort of see at least first cut how things are being used, and almost always people learn.
And within a month, you could be writing protection rules based on things here and there too.
Right. So I would say that's what we are most excited about, just scaling this out to a lot more customers that are just about to start up. So and growing the team. We went from 7 people in seed stage to now 35 roughly. So
And you're a Series A company
yes,
now,
we're
well capitalized and ready to grow. And there's a baby. That's awesome. All right, Mohit, we're at the 45-minute mark. Professor Tiwari, thank you so much. I appreciate it. Come back anytime when we can continue this discussion, because I feel like we can linger on a lot of these subtopics and have some real fun conversations. Thank you for coming on the show. I
Thanks so
appreciate it.
much, man. Really appreciate it.